limit x tends to 2, x squared plus 5x plus 6, 2x squared minus 3x. So going ahead, this is what I expect you to do diligently. Don't just do it as a part of the routine. You have to put x in the numerator as 2 and the denominator as 2 individually. So like 2 squared plus 5 into 2 plus 6. So this is 4 plus 10 plus 6. The basic idea is not finding the actual value, but just to check it is not 0. You just take the limit. Okay, taking the limit. It's only when both of them are 0, we need to do something. Otherwise, we just do it. If the numerator is 0 and the denominator is not, then the answer to the question is 0. But if the numerator is not 0 and the denominator is 0, then the answer is does not exist. Okay, so this is the answer. I repeat again. If this is a case, and if this is a case, then it does not exist. Okay, keep that in mind. So this is right hand side. You are here. That means you are greater than 5. So this is 5 plus h. So what are we getting here? We are getting 5 plus h minus, okay, this bracket is not needed. And this is 5 plus h. Okay. So now what happens here? In this case, this is 5 plus h, but this is the greatest integer function. Say, for example, f of x is greatest integer function. Then f of 1.9, okay, gives you 1. F of 2.01 gives you 2. Do you follow that? So when I'm plugging a number 5 plus h, that is 5.001, for example, what it gives me? It will give me just 5. So therefore, the answer, this is h. And then when we are taking the limit, what do we get? We get 0. Limit x tends to 5 minus x minus this. What answer will this give us? So if I write this as h tends to 0, 5 minus h, 5 minus h. So it will be 4.999. What do I get? I'll get 4. Okay, so this is the greatest integer function, the step function. So you have limit of h tends to 0, 5 minus h minus 4. We will have 1 minus h, and taking the limit, the answer will be 1. And here we are getting 0. So obviously, the modulus function we saw, we get plus 1 and minus 1. This is the greatest integer function where we get 0 and 1. But yeah, the left hand limit, the right hand limit individually exist, but they are not equal. So the function is, the limit of the function do not exist. So generally, I expect the students to write this. So as x approaches 2, the numerator and denominator approaches 0. Therefore, we factorize, okay? So limit of x tends to 2. Now to factorize, students, you can use long division or you can use the synthetic division, what you have studied in standard 10. So this is 2, 7 to the 14. So you get a 3, you get a 6 and a 0. So therefore, I have x minus 2 and I have 7x plus 3. For the second one, this is 3x square minus x minus 10. So that will be 3 minus 1 minus 10. This can be your rough work. There is no need to show this. Okay, but you can do it properly so that you don't do any error. Again, you will ask yourself a question that, can you cancel this? The answer is yes, you can. But why? Because it is not 0. So as x tends to 2, x is not equal to 2. Therefore, x minus 2 is not equal to 0. Writing this is important. Not writing this will you lose marks. So limit x tends to 2, 7x plus 3, 3x plus 5. And now you can check again by plugging x as 2 if the numerator and the denominator are becoming 0. The answer obviously is no, so we can take the limit. So we write, and this is 11. 17 upon 11 is the answer. Over here, students, they are not asking you to check. They are telling you that find k, the limit exists. So this is raised to 4. So the first thing that you do is to divide it. So x raised to 4, 3, 2, 1, and minus 1. Or long division, whatever you do. X tends to 1. X is not equal to 1. X minus 1 is not equal to 0. So what do I have? I have x cubed, x squared, x plus 1. Taking the limit, as x tends to k, x is not equal to k. Therefore, x minus k is not equal to 0. Limit x tends to k, you have x squared plus xk plus k squared upon x plus k. So we have to take the limit. So we get, we cancel k and you get k as 8 upon 3. 1 plus x, 1 minus x, and this is 2x. Again, you don't need to see or like do the working. It is very obvious when you put x as 0, in the numerator it becomes 0 and the denominator becomes 0. So because you need to write it. When you're solving questions from the textbook or from the assignment, you may feel that there are too many questions. So why to write the steps for all the questions? But in the exam, you'll be doing only one or few questions like this. So writing all the steps become important then. So remember, this is harmless. So this can be extended to the length of the question. You can take it down everywhere. So this is how I will write. Limit x tends to 0. A plus b into a minus b is a squared minus b squared. This is 2x. And here, I just take this with me. Limit x tends to 0. This becomes 2x. This becomes 2x. And I just continue writing this. Again, we come to the question where can we just strike it off? The answer is yes, but why? As x tends to 0, x is not equal to 0. So we get limit x tends to 0, 1 upon 1 plus x, 1 minus x. And the answer is half.